Okay, here we go. Chapter 1, Lesson 2, Sets of Rational Numbers for 7th grade. So basically this just comes down to practicing what we did previously, which is changing fractions to decimals and decimals to fractions. So it's going to give you pairs of numbers and tell you to replace each one with greater than, less than, or equal to. So we need to remember from 6th grade that if it opens to the left side, this means greater than, and if it opens to the right side, that is less than. And then you can remember that the alligator, this is my alligator, no wait, its foot's on backwards. Here's this foot, other foot, body, eyeball, scales. The alligator eats the bigger number. Okay? So it always opens up towards the bigger of the two numbers. So then it just comes down to which fraction is bigger or smaller. And since it's a little bit difficult to compare fractions with different denominators, we either need to give them the same denominator or change them to decimals. So if we, let's just change them to decimals. So let's say 5 in, 6 out. It's fraction of decimal, still T-bow. 6 still can't go into 5. We can go into 50 8 times. And now the difference here, since we just want to know which one's bigger, it's not so much the exact value that matters. So I'm just going to stop at this point. I'm going to say 0.8 something, but maybe that doesn't matter. And then I'm going to go to the second number. So we have 1/3. So 1 on the inside, 3 on the outside. So 3 can't go into 1, but it can go into 10 3 times. And now if I look at them, what is bigger, 0.8 or 0.3? And then you can see, well, 0.8 is bigger. So I'd use my greater than sign. So I'd say 0.8 is greater than 0.3. And that's all the problem requires. So we don't need exact decimal values. We just need enough to determine which one's bigger. Okay? So that's one way to do it. Make everything into decimals. And this is the preferred way when we get later on when there's more than two numbers. But another way we can look at it is if we compare our denominators, if we can find a common denominator between them. So if we say, here are my multiples of 5, 5, 10, 15, 20, 25, so on, so on, so on. Then my multiples of 10, 10, 20, 30. And we say, is there anything that they have in common? And there's 10. So I can change both of my fractions to something over 10, which is not too difficult because 9/10 is just 9/10. And then if I want to go from 4/5 to something over 10, so 5 times what is 10? That's times 2. Try to make a little x there. So I'll do times 2 here as well. So 4 times 2 is 8. And if you have two fractions with the same denominator, you just have to look at which one has the bigger numerator. So in this case, 9/10 is more than 8/10. Or based on the order, we say 8/10 is less than 9/10. So there's our answer. Okay. So then our third example, another way we can do this, so there's options here. We could use one of these two methods, either one would work. Or if we recognize, well, 6/9 and 4/6, neither of those are actually as simplified as they could be. So if I take 6/9 and I say, what can I simplify that by? Well, 6 is divisible by 3. And so is 9. So 6 divided by 3 is 2. 9 divided by 3 is 3. And then 4/6, that's not simplified either. So we can say 4/6 divided by what? Since they're both even, we know we can divide by 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. So we have, what's bigger, 2/3 or 2/3? And the answer is neither, because they are equal. Okay, so you can make them decimals. You can change them so they have the same denominator. Or if they're not simplified to begin with, we can try to simplify and then compare them that way. This one, I wouldn't really recommend too much. This one was just nice because they happen to be equal, but if they weren't equal, we would still have to compare the fractions. We'd have to go back to one of these two methods over here. Okay. And let's see. The last way we could do this, which I only recommend to people who are good at the previous ways, is we can use this method of cross multiplication. And say 7 times 1 is 7, and 8 times 2 is 16. Okay? And then we say which of those cross products is bigger? We say 16 is, so 2/7 is greater than 1/8. Okay? The reason why I don't recommend this is because it sort of skips a logical step here, which is what they did here is when you multiply by 8 and 7, you're actually rewriting the fractions. So we're saying we're multiplying top and bottom by 8 here. So 2 times 8 is 16 over 7 times 8 is 56. And then on the right side, we're multiplying top and bottom by 7. So that gives us 7 over 56. And then you're just comparing numerators. And the reason why this works is because how multiplication works, it doesn't matter what order you multiply in. So 7 times 8 will always be the same as 8 times 7. So if you need a common denominator, you can always just multiply your two original denominators together. Okay, so go practice those. It's all just a lot of multiplying and dividing, which again, sooner you get good at that, better off you're going to be. Okay. So then it gets slightly more complicated. It says put the numbers in order from least to greatest so that we don't make a mistake at the end. We're going to put L to G real big so we don't forget that's the order we want, least to greatest, smallest to biggest. And if there are multiple numbers, it's almost always 99% of the time your best bet to change everything to a decimal. So I need to know what is 3/5 as a decimal, and I need to know what is 2/3 as a decimal. And 0.65 is, well, it's 0.65. So that's nice. It's one number given. Okay. And if you look, since we have 2 decimal places here, let's go to 2 decimal places for everything else. And hopefully that'll be enough to give us a good answer. So 5 can't go into 3, but it can go into 30 6 times. And there's nothing left over here. So we're just going to bring the 0 up. So it's going to be 0.60. Okay. And then 2/3. Okay. 3 can't go into 2. Let me actually move this down. A little crowded there. Okay. So it can't go into 2, but it goes into 20 6 times. 6 times 3 is 18. And this is what we saw yesterday, that it's the same number we just divided by. So that's going to repeat. Only instead of putting bar notation, because we want to compare them, I'm just going to put a second 6 here. So that way, I have 3 decimal answers, and then I just had to put them in order from least to greatest. So the smallest one is 0.60, so that's 3/5. The next biggest is 0.65, and the biggest of all 3 is 0.66, which was 2/3. Okay. Step a lot of people will skip because they're lazy, but it's not really best practice. They'll just write these numbers in order from least to greatest, but you always want to go back to however they gave it to you, just to make it easier on your math teacher. Because if it was a multiple choice kind of question, this would be what your answer looks like. Okay. So even though you do the math, we just get these numbers so that we can compare them. So your answer always wants to go back to the original way the numbers were written. Okay? All right, one more, and then we're done. Okay, so same idea, least to greatest. So we have 7/8. We need as a decimal. We have 0.98. That's good, so I'm just going to write that one down here. And then 8/9. So again, top in. Oops, let me move it down some. 8 in, 9 out. Again, it gives us 2 decimal places. So let's just go to 2 decimal places. Especially in 7th grade. I don't think I've ever seen it where you needed more than 2 decimal places to figure out which number was biggest or smallest. Okay, so 8 can't go into 7, but it goes into 70 8 times, because 8 times 8 is 64, because if you 8 and 8, you would get sick on the floor, which is a handy rhyme, although a little gross. Alright, and then 8 goes into 60 7 times. 7 times 8 is 56, but like we said, we're going to stop here because I ran out of room. And this is enough to say, well, this number has to be less than 0.98. So I just need to figure out where 8/9 fits in. Okay, so let's see. 9 can't go into 8, but it goes into 80 8 times. Because 8 times 9 is 72. And then I get 8 when I subtract. And then if I bring this down, same as last time. This is going to be a repeating decimal, so I'm just going to bring up another 8. So now I have 0.87, 0.88, and 0.98, which is, they're written now in order just the way we wanted them. So our answer would look like, what was the big, our smallest? So 7/8, followed by 8/9, followed by 0.98. Okay, that's it. That's another lesson down, mostly based off of can you change fractions to decimals. Okay, let's go practice. Lots of